Okay, we're live now.
Awesome. Hello, everyone. Welcome to our machine learning workshop. We're just going to wait for 5 minutes. We're starting the webinar exactly on 12:05 Eastern Time. Thanks a lot for joining. Hello, everyone. On Friday noon. Let me see if we are seeing everything okay. All right, yeah, I can definitely see myself in the camera, so we are live.
Is it a little delayed?
There is a 10 seconds delay, I think. That is just a broadcasting delay. That cannot be, that's the fastest we can go. But yeah, so hello, everyone. We are just going to wait for a few more minutes while everyone joins in. I'm Siam Hussain, your host. And I have my friend Vivian Aranha with me, who is the guest today. We're just going to wait for a few more minutes, and we have Romeo, who is the moderator today. And yeah, so I guess let me see, Romeo, in your dashboard panel, are you able to see the people who are joining in? How many people are joining you? You are able to see those, right?
Yes, I can see them.
Okay, great. So let me open it up in my phone so that I can see them as well. So I am in Get Me Hired. I am live. Okay, great. Okay, sweet.
Nice to see you, he says.
Yeah, I can see a couple of people. So Alex, Roshan, Mahi, good. Thanks a lot for joining on a Friday noon. After the COVID-19 started, all the sense of time and everything kind of everything went away. So every day seems the same to me. So if you guys can say which area you guys are dialing in from, it would be great. I'm from Buffalo, New York. Vivian, where are you dialing in from?
I am from Atlanta, Georgia, but right now I am not in Atlanta. I'm in Indiana. Some of you probably know about that, but
Which part of Indiana are you in, Vivian?
I am in something called as Fishers, Indiana, a place a little north of Indianapolis.
Okay, got it. Yeah, I have been to Indianapolis. I have been to Fort Wayne. I don't know if you have ever been to Fort Wayne. It's another small city in Indiana. Yeah, so where are you guys from? I can see a couple more people joining. We're gonna start exactly in 2 minutes. So 12:05, we're going to start just while everyone joins in. So if you guys can say where exactly are you from? So Detroit, Vinod Kumar, welcome from Detroit. Joy from Bangladesh. Great to see people from a lot of different countries. Fatin from Michigan, Mount Pleasant. I don't think I've been here. Mehdi from Germany, Kotas, Germany. Vivian, you have a global audience here. And then Mamun from South Carolina, Alex from Northern California, US, Oklahoma, Mahi from Oklahoma, then Malik from South Carolina again, Columbia, South Carolina, Toronto, Chicago, Nepal, Baltimore. Tawhid from Baltimore. Hey, Tawhid, good to see you. So many known faces. Ishtiak from Toronto, and then Yadav, I think from Chicago. Then I went through Baltimore. People are scrolling. So I'm looking at my phone. I'm looking at this screen. So Saida from Richland, Washington State, Nepal. Brody from Las Vegas. Awesome. Vivian, you have a very global audience. So mostly definitely from US and Canada, but good to see people, different faces from different countries. So I think we can probably start. It's almost 12:05. So hi everyone, this is Siam. We are an online program for international students who are studying in US, and we help them land their first jobs as software developers. International students, whenever have strict timelines, so they have to get a job within first 90 days of their graduations, or else they have to go back to their home countries. We all came to US as international students, and we went through this struggle of not having any network, not having any professional experience, and we kind of started, get me hired in this mission that we wanted to create a community where we help international students going through this struggle and basically share this journey together. So thanks a lot for joining us again on Friday noon. I can see people from Dallas. Yeah, and Anika also joined. Good. So good to see like a full house. I think we can probably start. So Vivian is a long-term friend. I know him from 2013, I think. So it's been more than 7-8 years with Vivian. Vivian actually, like, go back to a long story, but Vivian has a lot of like connection with me in terms of like tech industry, and basically he has been one of the inspiration for me to get into software. And Vivian right now is a senior software developer at Delta Airlines. And yeah, I mean, he will be our guest who is going to talk about basically go more into the coding. I would actually just like to invite Vivian and talk about himself, and maybe I'll just pass the ball to Vivian. So welcome, Vivian. Thanks a lot for doing it for us. And yeah.
Sure, thank you. Yeah, anytime. I mean, this is my first webinar, just FYI. So I'm kind of overwhelmed by the number of people that have joined this, and I'm having dual monitor here. So if I am not looking directly at you, you still know that I am actually reading your messages or doing something on the other screen. So thank you for joining. I have been, as Siam said, we've known each other for a long time. He might be a businessman right now, but inside I know he's a software developer, and it's nice to see him do things like this. And he's probably give more details on that. But about me, I'm going to share my screen now. So it's always better to show than to tell. So this is, you can read more about me on LinkedIn. I'm currently, as you mentioned, work for Delta Airlines. It's a difficult time for us, but we are doing much better as compared to our competition, and we are having our flights cleaned and everything much better, and we are having some business come back. So it's good to see that. But yeah, I've worked at a bunch of different places. I think Remote Tiger is where we met, me and Siam, and worked on a bunch of projects before. There was some of the places where I worked are mostly startup companies. So you probably might not know about them. Like Personify Corp was acquired by someone else. Washington Post, you might know about it. It's a pretty big firm in a newspaper in DC area. I have, as he said, that I am a software engineer, but there's no actual definition for my role. I do pretty much everything at Delta. So I've touched things on, I'm working on blockchain projects. I'm working on, as you see, this is a data science or recommendation system based on machine learning webinar, which includes data science jobs. So I've also done that. I build models at Delta. I also do front-end websites, back-end work, so full stack development. I do mobile applications. I've done their employee-based applications. So I have my hands in everything, but I do mostly POCs. So I don't do full-fledged applications. There are teams that actually take over that. Next, going from there, just quickly. Okay, so next, this is my website. You can visit my website, see what I've done, what I am doing right now. Some of my projects are here. It might not be up to date, but they are here. You can look at my LinkedIn directly from here if you can't find it. Other things that I've done is I really like teaching. And some of the things that I've done is uploaded my courses on Udemy. So you can find them here. I stopped doing it a few years back because I realized it's much easier to upload it on YouTube, and that's why you'll see that I have created this data science course here. I've added all the videos in one single video. If you are one of those people who like to see everything in one stretch, so you can probably find it here. And then, okay, so someone asked me how long the webinar will be conducted. So we are trying to keep it for 1 hour, so 12 to 1. But it might be short, or maybe it might be a little bit longer. But 1 hour is our time that we are looking for. And then if you want to see in parts this data science course, it's here. And one of the prerequisites for this webinar was to look at these videos. But I've seen the views on this, and I don't think all of you have seen it. But I'll probably try to make sure I go slow and try to explain as much as possible. But if you are lost somewhere, you can always ask questions. I'll try to get to as many questions as possible today. But if there's something left, I'll come back and reply back on YouTube, or we'll have other sources which will let you know at the end of this of where to post it. And this webinar will be available live. So if you go to Get Me Hired website, you'll see like some of my courses available here. There are other instructors who are also posting. Introduction to Java is available over there, so you can look at if you're interested in Java, if you're interested in Google Apps Scripts, and this particular course, data science, is available here. Also, we have webinars on the top where you can see this webinar, or probably you got here from here. And also you'll see previous events which we have done, and you can click on them and look at the recordings of these webinars. So if you're interested. All the material from my YouTube course is available on my GitHub. So you can go to GitHub, search for my name, and you'll find a data science folder, which has all the projects that we have done in the YouTube session. And also whatever we do today, I will make sure they are available here. Okay, so from that, let's go to, I'll close this and I'll go jump in to our recommendation system. So what we're talking about today is, let me make it full screen. So let's see. So you guys can, so since I can see Siam here, if you see everything, give me a thumbs up. That's it. Don't have to talk about it. Okay, so let's talk about recommendation systems. I mean, recommendation systems is something that we've been using for a long time, for probably centuries. Not in the machine learning side of it, but no matter where you go, if you want to sometimes you ask your friends for recommendations, sometimes you ask your managers, your coworkers, or someone or other, you'll always keep on asking recommendations when you do things. The reason you ask for recommendation is you want to make sure you pick the best thing. And it's always, when you go for recommendation or asking for recommendation, you're not going to ask like, I love classic rock. So, and let's say Siam likes hip hop. So I'm not going to ask him for recommendation for music. I'm going to ask someone who knows, who is into classic rock. Let's say Romeo is in classic rock. I'm going to ask Romeo, can you tell me which new album or song would you recommend for me to listen? Have you been listening to anything? So he might recommend me something. So that's how recommendation systems works. And in machine learning, if you've seen my course, you probably see machine learning is nothing but training the machine to understand how a human behaves and kind of react to that as a human. So you go to a computer and tell them, give your details about you, and then it will reply to you based on your previous history or something or other. So we'll talk more on that, but first let's go through the slides. So implementing recommendation systems in Python is what we're going to do, and it's all for machine learning. Now, what does this do? So what, where, and when? How does it work? So recommend items, products, or services to users which he or she is most likely to be interested in. That's what recommendation actually means. Now, this is used everywhere, online or virtual or in real life, as I mentioned. So you get recommendations from Amazon, Walmart, Netflix, Spotify, LinkedIn, Facebook. There's TikTok, which is becoming very popular these days. Zillow. Your parents, of course, they say, don't get out of the house, wear your mask, or eat healthy food. So used in your daily life since you were born. Like, one of the things that my parents asked for recommendation was my name. I mean, it is Vivian, which might be confusing here, but in this country, but where I'm from in India, Vivian Richards were very popular as a cricketer. And some of you are from Bangladesh, so I'm very sure you know who Vivian Richards is. But if you've never heard of cricket, you probably don't know about him. So that's a recommendation system. In India, we also have arranged marriages, which is again a recommendation system, if you think about it. So it can be applied to everywhere, real life, virtual life. So the purpose is to make your users' life easier. As a product owner or an organization, you know your products and your users. With all the data available, you can provide the best recommendation to your users, in general, who are looking for something that they want or something very close to what they want. So that's what this system helps with. So we will cover two different types. One is content-based filtering, which means it doesn't have to do anything with uh, I'm getting distracted with the comments. There's some funny ones which have been posted. So, but again, I'll try to focus. Content-based filtering is where you look at the products and not the actual users who are using it. It's more like, if you like iPhone, I'm not gonna recommend you an Android device. I'm gonna recommend you the newer iPhone or something that is similar to that. If you're using Android device, I'm going to recommend you something that is Android related. But you don't look at the user in that. You look at the item that you're selling. Like people bought, let's say, I'm trying to. People bought a particular type of tea, then you're going to recommend something similar. If they're looking for a herbal tea, then you'll recommend something similar on that basis. So that's what mostly content-based filtering is. It's based on the content. Netflix does that, where you have movies of a particular genre and they will kind of recommend the similar genre over to you. Collaborative filtering is more like, it's more, as I mentioned in the start, about classic rock. I will ask Romeo about it. Why did I ask him? Because he's also into classic rock. So we have the similar taste. So I'm going to ask him. So that's collaborative filtering, where you look at users' data of who the users are, what the music is, and you kind of come together with recommendations based on how the users are using it and how it works. So let's go to the content-based systems. Now I'm going to do two real-life examples, and we'll use some data sets and we'll code it through. So let's go into, as I mentioned, content-based systems are completely, user preferences are not considered. So when considering content-based systems, user preferences are not considered because we take the user's requirement and completely focus on the items. We don't look at what the user has been using, but we see what he has bought before and similarly give him details on that. They will tell us that I want X, Y, Z, and then we can give them recommendation of something that is closely related to that. One example that we are going to use today is we'll get a data set for all the cars that are available, and we'll see what user wants, and based on that we can recommend him a particular car. We will try to do this with something called as nearest neighbor algorithm. And as you can see the name, if you don't know about the algorithm, it's as it says nearest neighbor. So the reason it says neighbor is people who have similar taste, they live next to each other. So that's why they are your neighbors. So similarly, if you think of a product, if you classify them or cluster them into one single, let's say, zone, and put all of the similar type of items together, then you'll get, if someone says, okay, let's say car examples, I can put all the luxury cars in one side, I can put all the economic car and sports cars in different sections. And now if someone says, oh, I want something like Honda Civic, so I can tell them, oh, let me look at the economy section, and I can say, okay, how about Yaris, or how about Toyota Corolla, something like that. If someone says, I want Lamborghini, so I can say, okay, how about Ferrari, or how about, so I probably go into that kind of section. So that's what nearest neighbor algorithm does. It uses unsupervised classifier. Now, if you have seen my machine learning course, I've probably specified that there are three types. One is supervised, unsupervised, and something that actually learns as and when you give data to it, reward based. It's when so unsupervised is what we saw in our in the example of where you don't actually train the system completely. We just provide data as and when it's available and let the machine cluster them together. Like the example that I gave you about the cars, where you put all the cars in clusters, sports cars, economic cars, so luxury cars. So that's how that works. Also known as memory-based systems, because it keeps track of items and then recommends an item based on similarity of a new item. Let's look at example that I'm talking about. So I'm going to go. Let's see if there's any questions. Yeah, let's skip this. I'm going to go back to get my data set. So the data set that I'm going to get is I use Kaggle.com. So this is a website which has, if I go to the home page, you'll see it has a lot of data sets available. It also has projects that people are solving. These days, the most hottest are coronavirus data sets, because people are trying to make sense out of it, try to see, even at Delta, what we're trying to do is we're trying to see when the economy is going to recover, when again we will reopen for business 100%. So these are some of the things that are available. You see Animal Crossing, it's a popular game these days. So that's data set on that. So the one that I'm going to use is something called as on cars, empty cars. So there's a bunch of different data sets available for this. I am going to download the first one that I got. And let's go ahead and open, since we are going to program in Jupyter Notebook, I'm going to try to open Jupyter Notebook. I'm going to put this file that I just downloaded in my folder. So I'm going to go to downloads, take my emptycars.csv, drag and drop it here. So I have that. Now I'm going to go here and start a new Python 3. So I'm going to start this. I'm going to give it a name. I'm going to call it content-based systems name. And if you have not seen some of these things, if you don't understand what I'm trying to do, you can always go back to the course and look at it, and you'll make sure it makes sense. But some of the libraries that we used is NumPy. So this is all in Python. If you don't understand Python, no problem. You can go back to the data science course. I've done from scratch how to use Python. If you've never done any programming language, you can look up there. So some of the libraries that we need are pandas and NumPy. NumPy is for numerical analysis. Pandas is for data analysis. So that's we'll use. We'll also use, since we're using nearest neighbor, I'm going to go and get that from sklearn. That's another NEIGHBORS. Let's hope I've spelled it right. If not, it will give me an error. Nearest neighbors. Run this. And it looks like it's probably fine. So I spelled everything right. So these are the libraries that we'll need. We'll get the algorithm from nearest neighbors here, and that will provide us the library that we algorithm that we need. We have data manipulation and numerical manipulation libraries here. Next, let's create a variable cars, and I'm going to read that CSV that I have imported. I called it emptycars.csv. So this will get me my cars database. I can just look at the entire data set, or I can just look at only a few of them by giving head. So it will give me 5 different cars that are available. The reason it says unnamed on here is because the data set has no value here, but it is the car name column. I have miles per gallon. How many cylinders? 4, 6, 8 cylinders. What is the displacement, engine displacement available? What is the horsepower, draft, weight of the in cubic, whatever tons that they use, Q-sec. I'm not sure what are some of these things. I think gears is number of gears that it has, but it doesn't make sense because Honda 4 has 3. But these are different information. So a user, let's say a user comes and says that I want to buy a car, but I don't know which car I want. But my requirement to buy a car is something that gives me 13 miles per gallon, or let's say 25 miles per gallon, something that gives me something that has 6 cylinders, something that has 200 engine displacement and has 250 horsepower. So now one thing that you can do is, let's say what happens if you don't have this machine learning or this particular algorithm available to you. What you'll do as a dealer is you look at these information, cross-check with your data set, and then try to recommend them something that is closer to their requirement, right? So that's one thing that you'll do. So I'll go ahead and do the same thing. So what I need is, I want to create some, what are my dependent variables that I need, independent variables that I need. So based on this, I need MPG, cylinders, displacement, and horsepower. So I'm going to say from my cars data set, I want to iloc. I'm trying to figure out if, I guess there's some questions, but I'll get back to them when I complete this. So keep them ready. and I'll say 1 to 5. So the reason I'm saying is this first parameter is how many rows do you want to use? I want to use all the rows. So that's why I'm not giving a range here. How many columns do you want to use? So I'm saying going to use column 1, 2, 3, 4, and 5. Why am I saying 5 here? Because if you've seen my videos, you'll probably, or if you have used Python, 1 to 5 means 1 to 4, don't include the fifth one. So that's how indexing works: 1, 2, 3, 4. So it'll give me all these 4 items in my X data sets. I can always look at these items. So if you see, it picked up these items from my actual data sets. So based on these, I want to come up with the nearest or a recommendation for this particular user. So I'm going to say, let me get my neighbors variable, and inside that I'm going to use my nearest neighbor algorithm, which I've imported. I'm going to say inside this, I'm going to pass what is the requirement, and then pass that. And when I run this, it will, so it will give me nearest algorithm value based on the data set that I have provided here. So actually, I guess I didn't fit this model to that. So that's why I don't have value. So let me fit it inside it. So I'm going to say neighbors. Oops. I just said, so first I have to set the data set, right? So I'm going to go here and say nearest neighbors and how many neighbors do you want to look at? So I'm going to say I want to, so there's a function that you give saying neighbors, saying how many items do you want? I want 1 for my solution, and fit X, the data set that I've created. So I'm going to run that. Neighbors, I think I've spelled something wrong, or nearest neighbor object has no attribute. Fix, not fix, fit. So once I have that, I can say, give me the neighbors, NEIGHBORS, and here is where I give my requirement. Run this, and it will give me, it will tell me the first value that it tells me is how off am I the user is. So there's a very high chance that he might not like it, but number 29 is the recommended value that I want to give him. So let's look at cars again, and let's see what is at number 29. So if you scroll down, you'll see number 29 is Ferrari Dino, is what is recommended for this particular user. Now, it's way too off because it has, of course, it has 6 cylinders, 25 miles per gallon, maybe 145 and 175. The requirement was 200, 250. So it's close by. That's what it's saying. Now, if I want to change the requirement, let's change it to something different. So I'll say 13 miles per gallon, 8 cylinders, 350 engine displacement, and 245 is the horsepower. I can run these again. Something messed up. Okay, 13, and I said 8. And now the output was way too off. 7, 8, 7, 8, 14, number 14. So that's what is recommended. So Cadillac Fleetwood. If I take something very, like let's say if I give these values 21, something that is available in the data set 21, I say 6 is the horsepower. I think I messed up this because, okay, let's try the same information one more time. So in this case, if you see, the error ratio is 0.3, which is very low, which is pretty good. And the car that is recommended is 23, and 23 is Camaro Z28. If you see 13.3, my requirement was 13, 8 cylinders, perfect. I said 350 horsepower and 245. So the only difference is this here. This was the only thing that I was wrong in my requirement. If the user comes up exactly with those values, of course, you'll get an error of 0, and 23 is the car. So this is how you can actually design your recommendation systems. In this case, the recommendation system using K-neighbors, and provide the best possible result for your users. So you can try around with this particular data set. It's available, or you can try something else and then play this. And this is how content-based systems actually work. So this is one of the examples using nearest neighbor algorithm. I'll also make a video of this and post it in our tutorial. And for now, I'll probably look at questions before we go to the next section, which is classification based filtering. So I'm gonna pass it to Siam while I look at the questions on YouTube. Siam, back to you.
Okay, awesome. Thank you, Vivian. I think, am I sharing the screen? I'll just pass it to Vivian. Vivian, are you good?
Yep, I am good. So if you can hear me back again. So yeah, thank you for that introduction. So I mean, that was pretty helpful. And even the webinar that you had on immigration this week, that was very helpful. I was on that. It gave me some insights on my visa situation, especially during these times. But yeah, and the platform that you have is pretty amazing, because when I remember when I graduated from school, I didn't even know much on, like, whatever I learned on school. When I went to real world, I realized that it's all useless, because what they teach in school is probably 10 years older than what they do it at workplace. And this kind of helps, whatever you're doing is helping. Like, if I wish if there was a platform like this, which would probably jumpstart my career, if I joined, where you kind of learn something and do something, and then you are well prepared for your interviews and things like that. So anyways, thanks for that. Going back to the question that we have, Borun Das, he's saying that about Netflix, what do they use, content based or collaborative? Now, if I was, I don't know what they use, but if I was Netflix, probably I would be using collaborative, because in content you're just doing based on the content that is there. But in Netflix, as you can see, as and when you look at more different types of TV shows or what you're doing, it will give you recommendations, and it also looks at users like you who are looking at similar content somewhere else, and what they are looking and what they like. So it's collaborative based from my opinion, because it takes the users inputs, that what users are watching. Because sometimes I am in mood of action movie, sometimes I want to watch a drama Bollywood movie. So there is no similarities between those two movies. So how can they know how, if they are in the key nearest algorithm, they fit that? No, they don't, because they are very far apart from each other, both the genres. So they look at what users are watching, and based on that, they will recommend that. So that's to answer your question. Next one is from Abhijit. Suppose I know how to use live. Okay, so these NumPy. So he's asking is, in job interviews, will they ask you how these things work? So in when I interview someone for these positions, I ask them. I don't ask them about the libraries. I ask them to do a coding session, and I give them a problem. Like, for example, this one, I'll give them a data set and I'll say solve this problem. So they'll have to use these algorithms, and then they implement it. Most of the jobs, when you go for interviews like these, they might ask you your familiarity with NumPy and Pandas library, of how they are structured and where you have used it. But the real test is in the implementation. So it's always good to have some, like, have a GitHub page with your problems and solutions that you have worked on, and that will help you help the interviewer understand that you know these terms and technologies. So that's how that works. um, Next one is next is from Anikua. I'm sorry if I'm messing up with your name, but I have a question. It says the user preferences are not considered content based filtering. Okay, so saying that he or she is saying that your user is giving you the preferences, right? So what happens is, think about this user. We don't know anything about the user right now. So for this car example, he said that I want these things. That are his preferences, but I don't know when he wants to drive, what he wants to do, where he's going to go with this car, how many miles is he going to drive with that particular car. So those information is when it comes to users preferences. In this, he's saying that I want X, Y, and Z, but I don't know why he wants that. What did he buy before? What did he buy after? What all cars does he is looking at? So what are the similarities between those? So I don't know any information about the user, but he's giving me a data set and he's saying, find me something similar to that. That's why it's not collaborative, it's content based, because you're looking at the existing data set that you have, and whatever you get, where you're plugging it in, that's what is happening. So that's why it's not user preferences, but it's user information. not what he's been doing with that data. Next one is I have been doing research in machine learning, and I'm quite familiar with training on algorithm and make prediction, but I have no background in software architecture. So you don't need software. I've seen people who are data analysts or business analysts, they have moved into data scientist role where they actually don't have to architect the software, but kind of build data models based on the data structure that they have. And it kind of goes with the another question that we have is, yeah.
Hey, Vivian, are you sharing your screen, by the way?
No, I'm not.
Okay, great.
No, I'm looking at a different screen for the questions. The next question is, can you tell what underlying data structure and algorithms is? So used for distance metric, it is using in the k nearest algorithm. I mean, there's a complete Wikipedia page on that, on how that works. But it's quite complicated. I've done it in my, I think in my school, probably fourth year or third year of my school. But what it does is it's a complex algorithm. At the end of the day, all you need to know is for this is like if you look at my classes, I've done in detail of how an algorithm works for linear regression. But after that, I stopped doing it because these are some of the things that people will not ask you during interviews or not needed for this particular position or job. K nearest algorithm, just to say in simple terms, is it takes all the data sets that you provide and try to put them together to the closest possible uh, way next to each other. So kind of making sure they cluster the entire data set into different sections and try to understand from that how they are close to each other. So that's all I can talk about this. If I have to create a class video on this, it'll probably be like 3-hour video just to explain how this works. But there's a Wikipedia page on that on k nearest neighbor algorithm. You can look at that if you want, if you're interested more. I can post the link in this webinar after this. I think that's all the questions that we had.
I have a question actually.
Sure.
So I mean, you know that I am a software developer. I'm not coming from the machine learning side of things. So, for example, I have understanding how, in general, like software development works, but I am enthusiastic about learning machine learning. How far, like, how long would it take for a person like me, and how much time do I have to invest per week, for example? Can you give me a ballpark when
Sure.
I'll be at least, yeah.
That's a good question, and I get a lot of these questions that, I am a C# developer, I am a mobile developer, I am a website developer. Can I get into machine learning? It sounds very complicated, and it's a lot of like, people use all these algorithms and all these terms. How can I even understand what they are? So actually, it's not that difficult. It's very intimidating. The reason is, as I always say, every single software development is very easy. It's just where you start. So I would say that start with a very simple, like let's say programming language. Now we use Python or R in machine learning. And if you know any programming language, Python is the most easiest programming language available. So it's much easier to move to Python. So that would be the first step. Now, don't be scared by some of the videos about all the algorithms and all the things that are out there, because you don't need to know everything. First you do is you start with the project. That's what I've done in my classes, to like go to linear regression. And if you look at linear regression, it might become a little scary because that's a 30-minute or almost 45-minute video of how linear regression works. We've done algorithm use of how it simply works. Now, when you're doing your job, you're not going to use this on a daily purpose. There's machines that actually are coded to do that. There's libraries that are available. As I give a very common example in my classes, like, if I'm hungry, there is 3 different ways to feeding myself. First one is I'll go and cook everything, buy everything from the grocery store, cook it, do everything by myself. Second one is go to the grocery store, get ready to eat, bring it home, heat it up, add whatever I want additional on top of it, which is what we are doing here. What we are doing is we are getting the libraries, and we just add to it whatever we want out of that particular algorithm. So there are tools available. Now, in one of the tools that we use, I think I'm not supposed to say the name of that tool because I think that's an NDA between Delta. So one of the tools that we use is, what it does is You just take the data structure, like whatever we find on Kaggle, and I drag and drop it into this tool. And what it does, it gives me all the different predictions that are available. It gives me APIs, everything that is available. So I think one of the questions was, how do I incorporate these machine learning models to complete software solution? I think I forgot that. So whatever you do in Python here, once you're done with this, you use something called as a pickle file. So you take your code and make a pickle out of it. It sounds delicious. And then at the end of you kind of deploy it, and then you make it an API, and the API will call this and say, okay, these are the data sets. What should I return back? So that's how it works. At the end of the day, you kind of take these solutions, you upload it to a server and deploy it, and make an API out of it. And that's what it gives. So this tool that I was talking about, you just give the data sets and it gives you an API endpoint, and it says, if you just send your queries here, you will get the solution. All you have to do is like, what are the dependent variables? What are the independent variables? Dependent variables is what you want to predict. Independent variables are what are you predicting this value off of. Like, in our example, let me share the screen again. Our dependent variable was, in this case, what car I want, which is this left side or the index here. And independent variables were MPG, cylinders, displacement, and HP. So that's how it comes together. So let's me move on to, so I think I answered your question, Siam, that is not difficult. All you do is like kind of start with a project and then slowly learn more on the details of it. If you just do the course online on your YouTube channel, you'll probably learn enough to start creating models. And from there, you can go crazy, you can go anywhere. As data science is a very vast field. I mean, there's data scientists, there's AI, there is machine learning, there's deep machine learning, so deep learning also available in there. So it becomes way too complicated. But if you want to just get your hands dirty, start with this, and then from there you can go crazy. There's a lot of resources online that you can play around with, and at the end of the day, you can see what are the different requirements for the job. Like, for example, today someone asked me, do you have experience with Tiger Graph? Now, I've never used Tiger Graph tool before, but then I was like kind of curious, what does Tiger Graph do? And just FYI, this is not an advertisement of this website, but I just got a email today saying there is a requirement for a job with this particular. Now, when I look at it, I see like it has big data analytics execution. So it looks like something that I'm using at my job, but something similar. It says try online demo, which means it's paid. So these are the tools that are available, which does things for you. And these are the things that you use at your real job. You don't use these kind of, I mean, there are some people who like to go hardcore and write Python, but there are tools available these days where you can drag and drop and your data set is available. So let's.
That answers my question, Vivian. Yeah. Mm-hmm. Thank you.
Okay, perfect. So let's go to the next one. The next one is classification-based collaborative filtering. Now, I'll probably try to go a little faster in this one because if you this is based on logistic regression, and it's used for classification, hence is best fit for. Just make sure this is okay. So as I said, the best fit for filtering data. We'll be using logistic regression, which is what we have done before in the videos. But what it does is it does basic classification. It does regression. So it is used for saying discrete values. Kind of there are two types of classification or let's say machine learning algorithm. One is logistic, one is linear regression. Linear regression has a vague set of values. For example, if you want to find a right house for your customer based on his pricing information, how much budget he has, then you get an entire neighborhood with the vast variety of numbers, and you try to see where he fits perfectly or what he's affording. Whereas in classification based, what happens is you kind of try to classify into buckets. That's what is here. So let's give another example of buying a product on your website. If you have Amazon or someone similar, when people come to, how can we best decide if a user will buy or not? So that is an example, true or false. Is he going to buy or not? Should I give him this product? Should I give him this product? So depending on his experience of buying or other users who have experience buying something similar to this user, you can kind of recommend them things. In this case, we're going to get information from the buyer's past history and also contextual information about different objects that are available or things that are available that we sell on the website, and how do they match with each other. So for this, so I've provided the data set here. I am going to go and download that. Let me go copy this URL and go and download this data set. This is again on Kaggle. It's based on online shoppers incentive. If you want to look at more details on this, you can read about the data set here, and it has all the information right here, what all it covers. It has data set on users based 12,330 sessions. So that's how much data we have. And based on that data, we can probably predict something, right, of if the user will buy something or not. That's the final goal of this particular project. So administrative data, this is the number of pages of this type that the user visited. And this is the amount of time spent in a particular category. Informational data, this is administrative data, this is informational data. Product related, and this is another product related. So if you see bounce rates, exit rates, when a particular user goes to a particular page, is it bouncing, is he exiting from the page value. So all the information is available here. I'm going to download this data set, unzip this, and so I have this. I'm going to just call it something simple. We call it online.csv, just so that I can import it easily. And as I mentioned before, I'm going to keep all these, put all this in GitHub after I'm done with this, so you can use this. So first one was content based. This one, I'm going to call it collaborative. Let's go collaborative, call it that. And let's look at how we implement this. So first, again, same thing that we'll do. First step is importing all the libraries for this particular. So I'm going to say import numpy as np. Let's say import pandas as pd, and from now same thing what we used in the previous project where we used nearest neighbors. We are going to use sklearn dot linear model, and this is where our library for linear logistic regression is available. So I'll run this. So I hope I spelled everything right. Yes, perfect. Looks like. Now I want to get my customer info pd dot. So these are all the existing current available customer sessions, and I saved it as online.csv. You can always check if it's right. If you see online.csv, that's available. So I have that. So once I've imported this data, next thing is let's look at the data. And these are the different data. So it got imported properly. All the information is available here. So that's all good. Next thing that I'll do is, I think there is some information that I need. For example, if you see here, my month is February, which I might need, but it's available in this. So what I want to do is I want to convert some of these data items into numbers. So I'm going to probably change numbers into 1, 2, 3, 4, 5, 6. I'm going to change this visitor type to returning visitor to 0. Then there is current or visit someone who's already been there, new visitor, returning visitor, and don't know. So that I'll kind of change that. So what I'm going to do is I'm going to use a file that I already have available. Let me try to find it, because this will need a little bit work to edit it. So I'm going to just import that from my computer. Records. See, I'm just, okay, I can, or the other way to do this is you can go to the file here and change all the data fields here, but that will take a lot of time. So I'm not going to go there, do that manually. I'm going to get one from my laptop. Just a minute, I got the file. I've done this project before, so I can use this here. Except open. So I have this file here. So if you see here, this file, I've just changed the visitor type into 1, 0, and 2. And similarly for the month, I've changed depending on which month it is. So I'm going to use this one instead of the one that we have. So let's get it from, is this the one? Quickly check. It's 12,000 records, so it's going to take some time. So I'm going to rather go to downloads and move this here. Replace, keep both. I'll say replace. I'll make this available in GitHub, so you don't have to do this. So I'm going to run this again. And now we'll probably see, okay, so the month and all the details are perfectly added here. Next step that I want to do is, let's go ahead and look at what all different fields are there. If you want to do that, you can do it using .info. And there you go, it shows all the different fields that are available. Now there are totally 17 fields available in here. The thing is, I don't need all the 17 fields. The one that I want to see is the revenue field, which is our dependent variable, which will tell us if the user will buy the product or not. I have history on them based on if they bought it before or didn't buy it before. So I'm going to go ahead and take my customer, all my independent variables into xinfo.ilock, where I want all the rows, but the columns that I'm interested in 0 up till 17, not 17, but up till 17. And I'm going to take all those values inside y, x. And y is my dependent variable, where I'll say I want all the rows, and the columns that I'm interested in is only 17 dot values. So I have x and y available. Now let's use logistic regression object. So let's create a object of logistic regression. And next, I'm going to fit same thing that we did before. We fit the logistic regression to my data set. Let's say dot fit. I don't know why I always mess up with the fit variable. So I fit, you get a warning here, you can ignore that. It says total number of iteration reached limit, because I have so much data, it says it reached your limit of number of data set that you can use, but I don't care about that. Now I want to give a user information and see if this person is going to buy or not a particular product that I'm giving from my website. So I have already created a data set. Let me see if it's available. Yep, here. So I've created 2 data sets, and these values are nothing but these values here, the 17 different columns: administrative duration, information duration, product related. So all these values have just created some random numbers and then added it here just to figure out if this user will buy or not. Now to predict this, if you probably remember how we did this in logistic regression, all we do is we say predict. There's a function available which says predict, and to this I'm going to give this user's value, new user, and if I want to see the values, I can just do. So according to this logistic regression, and based on the data that we have here, this user is not going to buy products from my website. So I'm not going to spend my energy or effort to advertise to this particular user. But what about someone else? Like I have another data set here. I'm going to use that. Run this. In this case, it's true. So what has changed? So there are some or other parameter which are dependent. Now, if you want to look at this from a person who's running a store and he wants to do it based on all the data sets that is available, he'll have to go through all this data and then try to make sense out of it, of how do I even know if this user is going to buy or not. So that's what machine learning does for you. You just give it the data set You say, I want to use logistic regression. And then if you change some values here and there, you can figure out if he's going to buy or not. I can just keep on playing around with different values. So if you see I change one parameter here, it falls. Two parameters, and came to false from true. So it all depends on how you set up your rules, or you kind of get information of the user from his previous experience. And from that, you can calculate it based on the model that you created using logistic regression. So this is how you can recommend using collaborative based system, where I have given an experience of different users in this particular case, and all the different products that you bought, and what type of products, which traffic, which region, what visitor type he is. And based on that, I can recommend to you as a business owner if this particular user is going to buy or not buy, and do you want to spend more money on that user or not, so that he can come back and buy from your website. So this is how Amazon kind of works and advertises to you. You probably have seen like things, examples, like a lot of people ask me, oh, so when I go to my website, I see like they're recommending me something which I just spoke about to my friend. How did they know? So you spoke to your friend, but Amazon probably has, is Amazon listening to you? No, they're not listening to you 24/7. They don't have, I mean, they have Echo Dot and all those things, tools that you have installed in your house, but they're not looking at listening to you, because that's illegal, first of all, and they have systems that don't spy on you all the times. But they have these recommendation systems which kind of look at your friends, what your friend bought based on his history, and what you are going to buy. So that's how it works, and that's how recommendation systems work. So these are two different types that we've done, but there's a lot of different available recommendation systems out there, and I will make some more videos on this and post it on the YouTube channel for Get Me Hired, and you can look at them. And for now, I don't know where Siam is. Siam, are you around? I don't see you on your chair, but I'll look at the questions if anyone has any questions, and also keep posting your questions on the YouTube channel, or Siam can give you more resources where you can post your questions on. I think they have a Slack channel where you can post. There's various resources where you can add these things. We look at condition. So in recommendation system, Dharamveer Yadav, hey man, I know you from Remote Tiger, so from my old coworker, asking recommendation system, how can we evaluate the performance? So if you look at my videos on logistic regression, and I've probably shown you how to evaluate the performance. In linear regression, they use something called as RMSE, and then in logistic regression, there's something called as confusion matrix, which will tell you how to evaluate the performance of a particular model. So that's my answer to that. Next one is I'm learning a few concepts on machine learning. I'm facing problems with data sets which has so many columns. How can I handle so many columns? Can I choose which features is important to me? So yeah, so this is a very challenging problem that everybody has, and I kind of get all the data sets and then try to use these tools that I mentioned before, and then I drop it into my tool and try to figure out what is important and what makes sense. A lot of times I just go to my business users and ask them, what are the fields that you actually want your information on? So that's one way of doing it, of asking. And the other thing is just understanding how they're related to each other. You can use some columns and keep on adding more and more columns as in when you do your coding. So that's another way of doing that. I have maybe which time series model of machine learning is better. I'm familiar with. I have no for time series. I have no idea on which one would be better, but I can give you more information later on that.
Hey, sorry, I was actually away, but yeah, thanks a lot for. I just went for bringing some tea, but yeah. So
yeah, so I've answered most of the questions. Everything is good, and I was telling them that you have like I asked them to post questions on YouTube channel, other than that, what other resources do you have where they can follow up?
Yeah. So basically, I mean, the follow-up would be that we will be sending, if you have signed up for this webinar through our email list, we'll be basically just sending in all the requirements for number one is that how to get the certificate. Basically, we'll be sending you some homeworks, and after you finish those homeworks, we'll be giving you the certificate. That's number one. And then if you want to be part of our community and for our next events, and also we'll be launching more open courses. If you want to be part of the community, Romeo, I think, has already posted in the YouTube we have a Slack channel called Skill Building Community. So just join that Slack channel. And yeah, if you, I guess like that's pretty much it. We, as I said in the beginning, that we have a batch which started on May 11th. If you want to get in, just apply today. If you have a little bit more time, apply within next 2 weeks. We have another batch starting June 1st. But yeah, that's all I wanted to say. Yeah, Vivian, are you like completely done, or do you have anything?
I'm done with this session. And yeah, if you have any questions, you guys can post it here. I don't check my emails, so don't send me emails, but you can post it here. And Siam always sends me the questions that are posted on the YouTube channel.
Yeah, well, I mean, thanks a lot, Vivian, for doing this for us. And yeah, like it means a lot for like taking your time with your busy schedule for, like doing this kind of webinars. These are super helpful for students. And yeah, just subscribe to our channel, and we'll be bringing more hosts in next months. And if you want to see more of Vivian, just let us know. And if you have any other ideas of what topics you want us to cover, just let us know as well. You have our email, you have received the email from us. So yeah, hoping to see you guys in our next event next month. And yeah, just stay with us.
Thank you, Siam.
Thank you, guys.
Thank you, guys.